you see this question, if n square is a perfect cube, which of the following statements is always true? N square is a perfect cube. Just through sheer observation we can say that a perfect cube is always of the form a power 3. But for n square to become perfect cube, can I say this perfect cube should be of the form a power 6? Why? Because think logically, a perfect cube is of the form a cube, but n square means it is a perfect square. Perfect square should have an power, even number. So what is the next multiple of 3 which is an even number? A power 6. N will become a cube. If n is a cube, what is the option that is present? N is a perfect cube. A simple understanding of the definition of a perfect cube, you will get this logic. Again I am repeating, n square is a perfect cube. N square is a perfect square. Perfect square means power should be an even number. Perfect square means power should be an even number. But for a perfect cube lowest form is a power 3. Left hand side it is saying that the power should be an even number. What is the next multiple of 3 which is an even number? A power 6. So n will become a cube. Answer is fourth option. Or you can take an example and you can do it. If n square is a perfect cube, n is a perfect cube. If I take 8 is a perfect cube. If I take 8 square is 64. 64 is nothing but 4 power 3. Are you all with me? Right? So with the example also we have proved that n is a perfect cube. Idea clear? Very easy question. Just nothing but an understanding of a perfect square definition and a perfect cube definition. Next, P is the product of 4 consecutive positive integers. Now I will solve this problem in 2 methods. Method 1. P is the product of 4 consecutive positive integers. Let the consecutive positive integers are a plus 1, a plus 2, a plus 3. Product means a into a plus 1 into a plus 2 into a plus 3. A square plus 3a into a square plus 3a plus 2. A square, if I call it as p, this is nothing but p plus 2, which is nothing but p square plus 2p. Add 1 and subtract 1. 2p plus 1 minus 1. So this is nothing but, I hope it is p square 2p plus 1. So p plus 1 whole square minus 1. That means to the product of 4 positive integers, if I add 1 to it, I will get a perfect square. I hope this important conclusion is clear to you. Again I am repeating, take any product of 4 consecutive positive integers, add 1 to it, that will result in a perfect square. These by using a variable method. Next I will tell you by using a numerical value method. P is the product of 4 consecutive integers. Which of the following statements is not true? Lowest product of 4 consecutive integers is 1 into 2 into 3 into 4, which is 24. P is perfectly divisible by 24. 24 is not a perfect square. 24 plus 1, which is a perfect square, this is also true. So which is not true? Fourth option is not true. I hope it is clear. You can take any other values. I took the lowest 4 positive integers because their calculation will be very less. There are 4 consecutive positive integers. What are that consecutive? 1, 2, 3, 4. Right? So if I do the product of this 4, 24, first option is right. P is not a perfect square. Why? Because 24 digital sum is 6. Perfect square digital sum should be 1, 4, 7 or 9. 24 plus 1, it is a perfect square. First 3 are right, so the fourth option is incorrect. I hope the idea is clear. But most importantly, I want to concentrate on this idea. Product of 4 consecutive positive integers. Product of 4 consecutive positive integers. Product of 4 consecutive positive integers plus 1 it is nothing but a perfect square. This idea is very important to me. Next question is based upon this idea. I hope the concept is clear. Answer for this question is option 4. Now, what is that idea that now we discussed? Product of 4 consecutive positive integers. Product of 4 consecutive positive integers. If I add 1 to it, I will get a perfect square. This is the idea. Now see, given a set of 4 consecutive integers, a possible value of their product is, this value is given. If I add 1, I should get a perfect square. 144 plus 1, which is 145. 145 is not a perfect square. First option is ruled out. 1728 plus 1, 1729. 1729 is not a perfect square. I hope it is clear, right? 1729 is not a perfect square. In case 625 plus 1, which is 626. 625 is a perfect square. First three options are incorrect. So answer for this question is 9. What is the concept that we used here? Product of 4 consecutive integers. On adding 1, I will get a perfect square. 144 plus 1 is 145. 12 square 144, 13 square 169. So 145 is incorrect. 1729. 1729 will be, suppose for example, 43 square, which is 1849. 41 square, which is 1681. 42 square, which is nothing but 1764. So this value is oscillating between 42 and 43. Anyway, 625 is a perfect square. 626 is not a perfect square. You can also check by using a digital sum. 6 plus 6, 12, 12 plus 2, 14, 14 is 5. A perfect square will have a digital sum 1, 4, 7 or 9. Very important last two problems. Product of 4 consecutive integers, on adding 1, I should get a perfect square. Previous problem and this problem, it uses this concept. Next question. Beautiful question. 120 into 122 into 124 into 126 plus n. It is a perfect square. But what we discussed, product of 4 consecutive integers, a plus 1, a plus 2, a plus 3 plus 1, it results in a perfect square. This is the concept which we discussed. All these 4 are consecutive positive integers. But 120, 122, 124, 126, they are not consecutive numbers, they are consecutive even numbers. Let us try to make them consecutive. 2 into 60, 2 into 61, 2 into 62, 2 into 63, plus 1. 2, 2, 2, 2, 2, 16, 16 into 60 into 61 into 62 into 63 plus n. 16 if I take common, 60 into 61 into 62 into 63 plus n by 16. 16 is a perfect square. So these is nothing but product of 4 consecutive plus 1. This is a perfect square. So n by 16 should be 1. If n by 16 is 1, n value will become 16. N value will become 16. I hope it is clear, right? N value will become 16. Idea clear? Or this is one way to solve the question. This is one way to solve the question. Idea clear? Another way to solve the question is by using the properties of perfect square. Perfect square never ends with 2, 3, 7 or 8. Perfect square digital sum should be 1, 4, 7 or 9. This is 0 into anything, 0, 0, 0. Suppose if the first option is 2, 0 plus 2 is 2. A perfect square cannot end with 2, 3, 7 or 8. If it is 3, it cannot end with 3. Like that you can eliminate the options where the perfect squares can never give you 2, 3, 7 or 8. One way. Another way is you check the digital sum. 120 digital sum is 3. 120 6 plus 2, 8, 8 plus 1, 9. You don't need to do others. 9 into any number is 9. 9 plus, if you see 16, 16 digital sum is 7. 9 plus 7 is 16, which is 7. Suppose, for example, suppose 14 is there. Suppose in the option 14 is there. What is 9 plus 14? 23. What is 2 plus 3? 5. Digital sum of a perfect square should be 1, 4, 7 or 9. It cannot be anything other than 1, 4, 7 or 9. Check by using the unit digit logic. Check by using the digital sum logic. If you are able to eliminate few answer options, then go ahead with these things. If you are stuck in more than one answer option using any of these two logics, this is the better logic. I hope you got the idea. Next one. Another beautiful question, sir. Consider a 4-digit number for which the first 2 digits are equal and the last 2 digits are also equal. How many such numbers are perfect squares? There is a 4-digit number AABB of which the first 2 digits are equal. Yes, last 2 digits are equal, and this number is a perfect square. And this number is a perfect square. And this number is a perfect square. How many such numbers are perfect squares? Very easy logic. A perfect square never ends with 2, 3, 7 or 8. So B, 2 is out, 3 is out, 7 is out, 8 is out. Are you all with me? Right. Now 0 is also out, because if it is 0, it will become 1100, 2200 and 9900. This will become 11 into 100. 100 is a perfect square, but 11 should have another 11 to become a perfect square. 22 into 100. These all the numbers 11, 22, 33 and so on 99. They contain only one multiple of 11. So therefore 0 is not possible. Are you all with me? 0 is not possible because last 2 digits will be same. So it will become 1100, 2200, 3300, 4400, 9900. All will have only one multiple of 11. 0 is not possible. 1 is not possible because already we discussed 9 square is 81, 11 square is 121. If the units place is 1, tens place will become an even number. But according to the question, tens place and units place should be same. 1 cannot be possible. 0, 1, 2, 5. 5 cannot be possible. Why? Because 5 square is 25. 15 square is 225. Any perfect square ending with 5, tens place is 2. But I want the last 2 digits same. 5 cannot be possible. Next, 6. 6 is also not possible. 4 square 16, 6 square 36. If the unit digit is 6, tens place will be an odd number. But according to the question, last 2 digits should be same. 6 is not possible. 7 square 49, 13 square 169. With 9, it is not possible. 0 not possible, 1 not possible, 2 not possible, 3 not possible, 7, 8, 9 possible. The only value B can take is 4. The only value B can take is 4. Are you all with me? By using the definition of a perfect square and some understanding of what will happen to tens place when the units place is a certain digit, I found out that B value is 4. Still I did not solve the question. One thing is very clear. The answer should be of the form AA44 because the last 2 digits are same. Now how can you get the answer very fast? Is it clear this slide? B, because the number is a perfect square, B cannot take 2, 3, 7 or 8. B cannot take 0 because if I take 0, I will get only one multiple of 11. I cannot have 1 because any perfect square ending with 1, tens place will be an even number. I cannot have 5 because the tens place will be 2. I cannot have 6 and 9 because the tens place will be an odd number in case of 6, even number in case of 9. The only value possible is 4. So the number B value which we got it as 4, AA44. How to find out how to find out these AA values. Idea clear, right? Now, I will discuss a logic. So, we have got till AA44. Extremely important logic. You take a number x, square that number. You do 50's complement. Add 50 or subtract 50. Or 100's complement. Or 50 multiples complement. All will have same last two digits. All has got same last two digits. You add 50, you subtract 50. You add 100, you subtract 100. On square, I will have the same last two digits. Same last two digits. Proof. Proof. Last two digits of a number. Last two digits of a number. You take the last two digits of a number. These is nothing but the remainder when I divide a number by 100. 123, last two digits is 23, which is nothing but the remainder when you divide a number by 100. 341, last two digits of 341 is 41. When you divide a number by 100, 100 3s are 300, remainder is 41. When you divide a number by 100, you will get the last two digits of a number. If I expand this 50 plus or minus 6, 50 square plus or minus 2 into 50 into x plus x square. 50 square is perfectly divisible by 100 because 2500 when divided by 100, remainder is 0. 2 into 50, 100 into any number when divided by 100, remainder 0. What is the remaining? Remaining is x square. Remember, very, very important key point. You do a number square, add 50, subtract 50. Do 50's complement or the multiples of 50's complement. Last two digits will not change. Last two digits will not change. If you add 50 multiples or if you add 100 multiples. Anyway, if 50 multiples are there, automatically 100 multiples are a part of 50's multiples. I hope it is clear. We will use this logic. We got the logic as AA44. We also got it as x square 50 plus or minus x whole square. Next is 100 plus or minus x whole square. Last two digits is 44. So 12 square is 144. 50 plus 12 is 62. 62 square is 3844. 50 minus 12, 38 square, which is 1444. 100 minus 12, 88 square is 7744. 7744. What is the number that we require? 7744 is of the form AABB. So answer is only one number exists and that number is 7744. In case if any student is finding any difficulty in finding the square so fast, go to our YouTube channel and type how to find the square of a number by Anil Nair. You will get a video. Square of a number finding is very easy. It's only one number, that is 7744. Again I am explaining. AA44. Last two digits is 44. The lowest natural number on square I will get 44 is 12 square. 12 square is 144. 50 plus 12 is 62 square, which is 3844. 50 minus 12 is 38 square, 1444. 100 minus 12 is 88 square, which is 7744. Now, if you observe, the only number which will satisfy this equation is 7744 and it is 1. I hope the logic is clear. Multiple concepts used in this logic. A perfect square never ends with 2, 3, 7 or 8. Other than 2, 3, 7 or 8, their properties I used it. X square 50 plus or minus x square, 100 plus or minus x square has the same last two digits. That logic also I used it. Entire idea is finding the units place, finding the lowest number on square. Please make a note of this important question. Next, how many perfect squares less than 1 lakh? Less than 1 lakh. How many perfect squares less than 1 lakh are there whose last two digits are same? So, last two digits are same. Last two digits are same. Last two digits are same. Now, if you see here, 1 lakh is nothing but 300. Suppose if I take 315 square, 315 square is 315 into 315. 5 5s are 25, 32 into 31. 32 into 31 is 32, 1s are 32, 32 3s are 96, 99, 99225. That means it should be around 316 point something. 316 point something. That means my perfect square should always be less than or equivalent to 316 point something. First, what is the nearest perfect square nearest 1 lakh is 316 point something. I hope it is clear, right? Because 992225 and 1 lakh there is a heavy difference of 7000. So I am sure that it should be greater than or equivalent to 316 point something. How many perfect squares less than 1 lakh are there whose last two digits are same? Last two digits are same means there are two cases that is possible. One is 0 0, last two digits are same, that is possible. So which all numbers that are possible? 10 square is 100, 20 square is 400, and so on up to 310 square is 96100. All these numbers will have last two digits same. I hope it is clear. What is the next number where the last two digits are same? Just now we discussed 44. One is 12 square 144. Next number is 50 plus 12, 62. Next number is 50 minus 12, 38. Are you all with me? So 50 plus 12 square, 50 minus 12 square. So 12 square I can take, 112 square I can take, 212 square I can take, 312 square I can take. It should be less than or equivalent to 316 point something. 38 I can take, 138 I can take, 238 I can take. I cannot take 338. 62 I can take, 162 I can take, 262 I can take. I hope it is clear. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? And from 10 square to 310 square. Total 310 numbers are there where the last two digits are 0 zeros and the remaining numbers will have 44. Why only these two cases are possible? That is what in the previous problem we discussed, that AABB last two digits are same only under these two cases, 0 0 and 44. 0 0 we eliminated in the previous problem because it's a perfect square. I am getting only one multiple of 4. It's a classical example of a counting based problem. This kind of problems never solve it in the first innings. You can solve it in the second and the third innings because this is nothing but the counting problem, counting based. Anything that it involves counting. Here the first calculation it finding out what is the nearest perfect square. That is the first major thing. Second thing is finding all the values, finding 50 plus or minus x square. Adding all the values you will get the counting. 10 to 310 square, whatever I wrote it out in the circle, you have to count that numbers. All these numbers you have to count it and add it. I hope this question is also clear to you. Clear? Next one. How many 4-digit numbers are of the form AB, AB? Okay, I think here wantedly I left some slide because I wanted to discuss some more questions. Right? Now see here. AABB is a perfect square. You can ask a question like this. Find the value of A plus B. AABB, which value we got? 7744. So A plus B value is 11. Or he can also ask A triple B is a perfect square. If A triple B is a perfect square, same thing we got. BB same means 44. 12 square 144. 50 minus 12 38 square is 1444. 50 plus 12 68 square is 3844. 100 minus 12. 88 square is 7744. Here did we took 88 square? Now here one more case. This is the problem with counting. 88 square also we have to take. 88, 188 square and 288 square also we have to take. Because 3 cases. That's exactly what I wanted to say. One case if you miss it, you might get incorrect. 12 we did it. 12 is the base. 50 minus 12, 38 we did it. 50 plus 12, 62 we did it. 100 minus 12, 88. We forgot to do it. So all these cases needs to be counted. Be careful in this kind of questions. Be careful when you are solving this kind of questions. I hope the logic is clear. Next one. When we are doing this, suddenly that came into our mind. Now a triple b is a perfect square. A triple b value is 1444. 1444. So a plus b value is nothing but 5. A plus b value is nothing but 5. I hope it is clear. Like this innumerable number of questions, you can create it and you can solve it. Suppose another question. How many 4-digit perfect squares? How many 4-digit perfect squares has tens place 1? Has tens place 1. There is a 4-digit perfect square. Tens place is 1. Tens place is 1. First of all, it is a 4-digit perfect square. It cannot take 2, 3, 7 or 8. We discussed one beautiful logic that will help you here. Tens place is odd. Tens place is odd only under a case where the units place is 6. Are you all with me? That is one of the property of a perfect square which I discussed. Tens place will be odd in a perfect square only when the units place is 6. 4 square is 16. 4 square is 16. So if 4 square is 16, another values will become 50 minus 4 is 46 square, 2116. 50 plus 4 is 54 square, which is 2916. 100 minus 4 is 96 square, which is 9216. How many 4-digit perfect squares has a tens place 1? 3. Directly you are getting 3 because you know this property. I hope the idea is clear. Tens place will be odd only when the unit digit is 6. So directly the last 2 digits came out to be 16. 4 square is 16. 50 minus 4, 50 plus 4. 100 minus 4, 100 plus 4. 100 plus 4 is 108 square, which is 11664. I want a 4-digit perfect square. Idea clear? Like this, questions can be created in whatever way that is possible. Next is also a beautiful question, sir. How many 4-digit numbers are of the form AB, AB? Okay. Where A and B refers to the digits of the number. This is a perfect square. This is a perfect square. The number is of the form AB, AB. Now listen carefully. B is there in units place. A is there in tens place. B is there in hundreds place. A is there in thousands place. 1000A plus 100B plus 10A plus B. This is the value. Again, I will write it little in a bold. Bold, I will write it. I hope you are all enjoying the class with a quality questions being discussed. High quality problems only I will discuss. A is there in thousands place, so 1000A. B is there in hundreds place, so 100B. A is there in tens place, so 10A. B is there in units place plus B. 1000A plus 10B, 1010A. 100B plus B, which is 101B. Taking out 101 common, this is nothing but 10A plus B. 10A plus B. Now see here. And he is telling that this number is a perfect square. This number is a perfect square. This number cannot be a perfect square. Why? Because 101 is there. 10A plus B. 10A plus B should give you another 101. then only the number will become a perfect square. Perfect square means number multiplied by itself. Either 10a plus b should give you 101 or it should give you 101 into some perfect square. But 101 is not possible. Why? Because a and b are the digits. If a and b are the digits, what is the maximum digit value a can take? 9. What is the maximum digit value b can take? 9. What is the maximum value 10a plus b can take? Which is 99. Even if I take 101 into 99, it is not a perfect square. A perfect square means power should be an even number or power should be 0. When 101 is outside present, this number should give you another 101. Then only it will become 101 square. If it becomes 101 square, then only it is a perfect square. Inside cannot give you 101. Why? Because a and b are digits. The maximum value a digit can take is 9. 10 into 9 plus 9 is 99. Beautiful question. None of the numbers which are of the form AB can be a perfect square. Idea clear? I hope it is clear. Idea clear, right? Now, next question. Clear, right? Next one. Or in case if you want it, you can also use it by using AB is a perfect square. AB is a perfect square. It is a 4-digit number. What is the lowest 4-digit on perfect square? That it will be 16, 16, 25, 25, 36, 36, 49, 49. Are you all with me? 6 square, 7 square, 64, 64, 81, 81. These are all the possible cases. Yes or no? Try to use the digital sum concept and eliminate. The digital sum of a perfect square should always be 1, 4, 7 or 9. Let us eliminate. 7 plus 7, 14. It is 5. It cannot be possible. 7 plus 7, 14. It is 5. It is not possible. 9 plus 9, 18. Which is 9 could be 8, not possible. 1 plus 1, 2, not possible. 81, 81, 9, this could be possible. 36, 36, 81, 81, these two may be possible. 3600 is 60 square. 60 square is 3600. 61 square is 3721. This value is in between 60 and 61. Not possible. 90 square is 8100. 91 square is 82, 81. These lies between these two values, not possible. These two not possible. So answer 0. In case if you want to use numerical values also, you can use it. If you know the concept, the digital sum of a perfect square is always 1, 4, 7 or 9. I hope the idea is clear. Method 1, method 2. Method 1 is checking 10a plus b, can it give you 101? It cannot give you because a and b are digits. The maximum value a digit can take is 9. 10a plus b maximum value is 99. Next one, how many 4-digit numbers are of the form a triple b and this number is a perfect square? Already we solved this problem. The last 2 digits are equal for 44, right? 1444 is what we got it. From where we got 12 square is 144. 50 minus 12 is 38 square 1444. 50 plus 12 is 62 square 3844. 88 square is 7744. This is the number that we got it. Please type how to find the square of a number by Anil Nair so that you will find these calculations very, very fast. Those of you who want to know how I did it fast, I used the logic how to find the square of a number as a plus b whole square, which is a square plus 2ab plus b square. This logic I used it. I hope it is clear. Please watch that video so that you will understand multiple ways how to find the square of a number. All the questions that we discussed are nothing but a perfect squares logic. Now see here. There are a lot of good problems that we are going to solve. Such a good problems that we are going to solve. Now, you can do a lot of these questions by using. We will solve this question. How many values if q is 1 factorial plus 2 factorial plus 3 factorial and so on up to n factorial, q should be a perfect square. Q should be a perfect square. If n value is 1, q is nothing but 1. 1 is a perfect square. If n value is 2, q is 1 factorial plus 2 factorial, 3. A perfect square never ends with 2, 3, 7 or 8. If n is 3, q is 1 plus 2 plus 6, which is 9. 9 is a perfect square. If n value is 4, q will become 1 plus 2 plus 6 plus 24, which is 3 plus 6, 9, 33. A perfect square can never end with 2, 3, 7 or 8. It is from 5 factorial onwards. From 5 factorial onwards, unit digit will become 0. Unit digit is 0. So 0 plus 3, it will become 3. You don't need to do from 5 onwards. From 5 factorial onwards, unit digit will become 0. So only 2 values are there, which will give you the q value perfect square. What is the concept that I used in this question? A perfect square never ends with 2, 3, 7 or 8. From 5 factorial onwards, unit digit is 0. So if from 5 factorial, if you add any number till 4 factorial, till 4 factorial I got the unit digit 3. 3 plus 0, 3. A perfect square can never end with 3. From 1 to 3, q is 1. N value 2 I got unit digit 3, n value 3 I got 9. 1 and 9 are perfect square. A simple definition based problem. A perfect square never ends with 2, 3, 7 or 8. And there are only 2 values in this question which will make this question a perfect square. Very conceptual questions. Very, very conceptual questions. How many non-negative, other than negative, how many non-negative integers are there such that n factorial plus 10, it is a perfect square. Perfect square. N value, non-negative means other than negative. N is 0. 0 factorial plus 10. 1 plus 10 is 11. 11 is not a perfect square. N 1. 1 factorial plus 10. 1 plus 10 is 11, not a perfect square. N value 2. 2 plus 10, which is 12. A perfect square can never end with 2, 3, 7 or 8. N value 3. 3 factorial. 3 factorial is 6. 6 plus 10, 16. 16 is a perfect square. 16 is a perfect square. Now see here. N factorial. 4 factorial. 4 factorial is 24. 24 plus 10, which is 34. 34 is not a perfect square. Suppose if you see n 5 factorial onwards, 5 factorial onwards, you do only till here. You don't need to do 4 factorial also. Now see here. Can I say n from 4 factorial onwards, 4 factorial, 5 factorial, all are divisible by 4, yes or no? 4 factorial is 4 into 3 into 2 into 1, 5 factorial is 5 into 4 into 3 into 2 into 1. So, till n value 3 you do it, it is enough. Why? Because n factorial plus 10, it is k square. K square is a perfect square. It should be of the form 4p or 4p plus 1. Yes or no? A perfect square should be of the form 4p or 4p plus 1. From 4 factorial onwards, this is divisible by 4. 10 is nothing but 4 into 2 plus 2. 4k plus 2. 4k plus 2 form does not arise. That means from 4 factorial onwards, I will never get a number when you add 10, it becomes a perfect square. So only one value that is possible, that is n equivalent to 3. I hope it is clear. 3 factorial 6, 6 plus 10 is 16. It is a perfect square. Excellent question, sir. A very, very good question which explains how to use the nature of a perfect square. A perfect square is always of the form 4k or 4k plus 1. From 4 factorial onwards, n factorial will be divisible by 4. N factorial is divisible by 4. 10 is nothing but 4 into 2 plus 2. Left hand side, n factorial divisible by 4. 10 is 4k plus 2. 4 into something plus 4 into k plus 2. Left hand side I am getting 4 into something plus 2. Can a perfect square take value of the form 4 into k plus 2? Not possible. So from 4 factorial, none of the values, it is not possible. Extremely good question, sir. If you do not know that if perfect square will be of the form 4 into something or 4 into something plus 1. This question you will take it as a very, very difficult question. This how I will make the things very, very easy for you if you attend my live class. Another question. Beautiful question. Beautiful question. Seems a very, very difficult question. Typical cat level question. X square minus 11 into y factorial is 2003. Now see here. X square equivalent to 11 into y factorial plus 2003. Step 1. I will substitute y1, y2 and y3. Step 2. Step 2. From y greater than or equivalent to 4, y factorial is divisible by 4. Are you all with me? So x square is nothing but 11 into y factorial plus 2003. This is divisible by 4. 0, 3. 0, 3 means 4 into something plus 3. Right hand side is becoming 4 into something plus 3. A perfect square will always be of the form 4 into something or 4 into something plus 1. 4 into something plus 3 is not possible. Y greater than or equivalent to 4, no value is possible. No solution is possible for y greater than or equivalent to 4. Y equivalent to 1. X square will become 2014. 2014 digital sum is 7. A perfect square can never take 1, 4, 7 or 9. Y is 2. 2 factorial is 2. 2 11s are 22. It is 2025. X is 45. Yes, one value I am getting it. 45 square is 2025. Y is 3. 3 factorial is 6. 6 11s are 66. 66 means 2069. 2069. It is not a perfect square. Why? Because the digital sum of 2069 is 8 plus 9, 17, 8. A perfect square digital sum is 1, 4, 7 or 9. These are not possible. Y1 not possible, Y3 not possible, Y greater than or equivalent to 4 not possible. Only one value will satisfy. Very, very good question. None of these questions you will find it in anywhere in any of the YouTube channels, right? Maybe you will find, but a full page solution will be there. They will not even teach you because they will say that these questions will not come in your examination. For me, these are the exact questions where an examiner try to test your conceptual understanding. There is no formula in this question. There is an absolute clarity to know whether you know the definition of a perfect square. Beautiful questions. Only one value. I hope the idea is clear. Is it clear? Third question. Find all the pairs of positive integers such that x square minus 5y square is 1, 2, 3, 2. X square minus 5y square is 1, 2, 3, 2. See another question. Oh, people will do traditional method. Traditional method will take more than 3 minutes to solve. You can ask any of your teacher to solve this question. Minimum 3 minutes he will take this question. Now look at Anil Nair classes way of solving this question. X square minus 5y square is 1, 2, 3, 2. Unit digit is 2. When you multiply any number by 5, unit digit will be 0 or 5. Are you all with me? Something minus 0 should give you unit digit 2. This is unit digit 2. Something minus 5 should give you unit digit 2. This is 7. But x square is a perfect square. A perfect square can never end with 2 or 7 in this case. Answer is no value. A 3-minute question became a 5 seconds question because you have attended the perfect square logic. Tell me one logic which I did not use. Here, perfect square digital sum is always 1, 4, 7 or 9. I used it. Perfect square never ends with 2, 3, 7 or 8. I used it. A perfect square is always of the form 4 into something or 4 into something plus 1. That also I used it. That's exactly conceptual clarity always will dominate formulae based learning. My 2 hours live class is equivalent to you listening to minimum 20 hours of formulae based learning. Keep my live class and keep another live class on the same topic. Do the comparison. At the end of watching my live class, you will see that you have understood crystal clearly when to use, where to use, how to use concept starting from basic to advanced level. In my class, it is not a question and a problem solving. If you are interested in me solving every question, definitely you are going in the wrong direction. You are wasting your time in watching so many live classes where a question and a solution is there. For me, a question and a solution and how to think logically away from formula driven, how to solve this question in the most non-familiar, non-formula way of solving this question. Can anybody thought that this question can be solved by using the unit digit? You probably might have thought that 5y square means Anil sir might use the logic of divisibility rule for 5 something he will do it. It's a simple observational analysis that will solve you this question. Try to give this question to the teacher who was teaching you the number system in your coaching center. You will be surprised to know. Watch my classes if you are going for any classroom coaching. You will be the best in the class and you will solve the questions faster than the teacher who is solving the question if you attend all my number system live classes. I can say it with 15 years experience and having solved singularly close to 90,000 plus questions only on number system. Is it clear? Another way, another logic. Find all the positive integers xy such that x square minus 3y square equivalent to 8. Another beautiful way of solving this question. X square minus 3y square equivalent to 8. X square equivalent to 3y square plus 8. When I saw this question, immediately a thought came into my question. X is nothing but a natural number. X is nothing but a natural number. A natural number. Here 3y square is there. That means it's a multiple of 3. That means any natural can be either divisible by 3 or gives a remainder 1 or gives a remainder 2. When you divide a number by 3, you will get only 3 reminders, either 0 or 1 or 2. So it will be either 3k or 3k plus 1 or 3k plus 2. If I square it, divisible by 3, 3k plus 1 whole square. 3k square divisible by 3. 2 into 3k divisible by 3. It gives a remainder 1. 3k plus 2 whole square. 3k square divisible by 3. 2 into 3k into 2 divisible by 3. 4 when divided by 3. Remainder 1. That means x square can also be of the form either 3p or 3p plus 1. Are you all with me? It is not only 4p or 4p plus 1. It can also be 3p or 3p plus 1. Why it is 3p plus 1? Because any natural number when divided by 3, remainder will be 0 or 1 or 2. 3k or 3k plus 1 or 3k plus 2. If I square it, 3k plus 2 square. 3k square divisible by 3. If 12k divisible by 3. 4 divided by 3, remainder 1. So from now onwards, another important logic in perfect square is, it will be either divisible by 3 or it gives a remainder 1. So either it will be divisible by 3 or it gives a remainder 1. Anyway, it is divisible by 3. 8 is of the form 3 into 2 plus 2. A perfect square can never give remainder 2 when divided by 3. So answer is no solution. Another beautiful concept, another beautiful way of solving this question. I hope the idea is clear. X square minus 3y square equivalent to 8. Because the coefficient of y square is 3, I found out the nature of a perfect square. What happens when it is divided by 3? A perfect square is always of the form 3p or 3p plus 1. Right? Unit digit logic. Any factorial starting from 4 onwards, it is divisible by 4 factorial, 5 factorial, 6 factorial divisible by 3. What is the logic that I used it? A perfect square will always be of the form 4k or 4k plus 1. 4k or 4k plus 1. A perfect square never ends with 2, 3, 7 or 8. 2, 3, 7 or 8. Now see here. Now I hope it is clear, right? Idea clear? This is the session 1. Session 2, I am going to solve a lot of these problems where you are going to do a lot of mistakes. I don't want any student to get confused. I hope session 1 is clear. Now what I will do is, I will just do a revision of whatever I discussed it. What are the concepts that I discussed? Concepts. In session 1, what are the concepts that I discussed? Definition of a perfect square. A perfect square never ends with 2, 3, 7 or 8. Application of this on exam model questions. Simplifying the question in seconds. A perfect square can never have digital sum other than 1, 4, 7 or 9. And its application. I hope it is clear. Other than 1, 4, 7 or 9. If the unit digit is 6, then only the tens place will be an odd number. Otherwise, the tens place will be an even number for a perfect square. Every perfect square will be of the form 4p or 4p plus 1. We also discussed every perfect square can also be of the form 3p or 3p plus 1. 3p or a 3p plus 1. Now see here, all the problems. In the second session, I am going to solve some other advanced models made into an probably the easiest question. Looking at a question itself, you can answer it. Once you are comfortable with this session 1, let me revisit all the problems whatever I discussed. I hope the first question is clear. One is a traditional method, another is a digital sum approach. Next one. Next question. Neither a perfect square nor a perfect cube. I hope it is clear, right? Third one. An important logic based on a what happens if a number is a perfect square and a perfect cube. Product of 4 consecutive integers plus 1. It is a perfect square. Problems based on that model. What if they are not consecutive integers? How to make it into a consecutive integers? x square 50 plus or minus x whole square, 100 plus or minus x whole square has the same last two digits. Problems based on that model. I hope these are all the problems are extremely clear to you.